Spacecraft returning to Earth must survive an incredible ordeal. They travel at hypersonic speeds, converting kinetic energy into searing heat that could vaporize almost anything. Let's explore how spacecraft endure this inferno.
At hypersonic speeds, air can't simply move away from the spacecraft.
Immense pressure and heat build in front of the spacecraft, forming a shockwave. This shockwave causes most of the re-entry heat. Spacecraft need heat shields to protect onboard instruments and crew. Join us at the SpaceX podcast, where they talk all about the unique ceramic tile system.
We actually have some heat shields here. So these are what's doing all the work on Starship right now. There are 18,000 hexagonal heat shields like these. So this one that I have is flat, like this is what would be positioned on the flaps of Starship, whereas Shiva has something a little different.
Yeah, the one I have would be on the curved surfaces of Starship. I'll just put it in frame here. So we've got these attached at various points around the vehicle. Like you said, Kate, 18,000 of these tiles around, and they're doing the work to make sure that the structure of the vehicle doesn't carry all that thermal load, so we can recover the vehicles eventually and get to rapid reuse on them.
They're really lightweight. They sound a little different than I would have expected them to, but they are ceramic. And these are what's helping Starship survive through this period of entry.
Now let's look at the different types of heat shields that engineers have designed to protect the spacecraft from this intense heat, allowing it to safely make it back to the ground.
Ablative heat shields. These shields sacrifice material.
Heat causes evaporation, carrying heat away and creating a protective gas layer.
Example, Apollo and SpaceX Dragon. Thermal soak heat shields.
Heat is absorbed into the material and then radiated away from the spacecraft.
Example, Space Shuttle. Ceramic tiles.
Starship is built with stainless steel that has some heat resistance. The windward side, facing the atmosphere, will use heat-resistant ceramic tiles. Unlike the Space Shuttle, these tiles are mechanically attached, not glued. Robots will install these tiles for efficiency. If needed, SpaceX may add transpiration cooling in areas of excessive heat. The true test of Starship's heat shield is its orbital flights and re-entries.
With reusability as its key goal, these heat shields must prove themselves time and time again.
Fascinating, isn't it?
There's even more to learn about heat shield design and the incredible forces they endure. Let's hear some expert perspectives on this.
Starship is pretty unique in the way that it re-enters, especially for something reusable. The closest parallel has been the Space Shuttle. When we're comparing Starship to like when we bring a Falcon 9 booster back, we're talking about 20 times the energy given the velocity that we're moving at, and all of that energy just gets converted into heat, and then we need to use those tiles to just help dissipate that heat. They're not ablative like you would see on something like Dragon, which uses an ablative in the capsule shape. So they are these tiles that are made to be reusable. So any data we're getting on the actual temperatures it was seeing during heating, all of that is just really hugely valuable. Where Starship is really unique is, and Kate and Shiv have talked about it a couple of times, is once we're through this kind of hypersonic section and we get down to the subsonic, and that's where we really learned a lot and proved that Starship's really just its basic shape could work, and we did that during the suborbital campaign. Again, if you compare it to the shuttle, which entered, it had the wings, it had a similar heat shield system, but it had wings, and then was almost flown like a glider once it re-entered and was down to those subsonic speeds. With Starship, we're not doing that. We're just coming straight down. We'll hit terminal velocity, which with Starship is around 200 miles an hour, and then we use a flip maneuver to ignite those engines, do a landing burn, and then touch down on the ground. So you don't need a runway. We're doing that, again, designed because when we go to the moon, when we go to Mars, there's not going to be a runway there for us, and so that propulsive landing is going to be really important. This is an animation of pretty much what we were just watching on actual Starship video, which is pretty incredible. but we go through peak heating. One of the benefits of today's trajectory, actually, we got closer to what the heating profile will be on just a normal mission when you compare it to our previous flight.
Starship's heat shield is its only defense. Here we see the ceramic tiles glowing red hot, designed to withstand temperatures exceeding 2,200 degrees Celsius. But will it hold? Experts raised concerns about the heat shield's ability to handle the extreme re-entry stress. Starship was aligned with the intended trajectory during descent. However, it began to roll and the pitch angle shifted suddenly. This deviation caused the aft of the spacecraft to enter the atmosphere first, potentially risking its safe landing. What happened to Starship? Did the heat shield fail, or was it a communication loss?
Based on the information we've seen, what's your opinion?
Is the design of the Starship feasible, or does it need to be modified? Let us know in the comments below.
Starship's trials and triumphs remind us that reaching for the stars isn't easy.
It takes ingenuity, it takes the risk, and a dedication to progress. SpaceX pushes boundaries, sometimes encountering setbacks like the potential heat shield issue. But they learn, they adapt, and they push forward. Their ambition fuels progress, inspiring a new generation of space explorers. Will they conquer the challenges of re-entry on the fourth Starship test flight, or will they need a radical redesign? Share your thoughts in the comments below.
And if you believe in the power of SpaceX's innovation, hit that like button, share this video, and subscribe for more updates on their incredible journey. Thank you for watching, and I look forward to seeing you in the next video.